Hakuna Matata, everybody. It's Tuesday, August 6th, and we're back at the wiring thing. Let me get my other light on here. So, I don't remember if I mentioned all this before. This bus is equipped with multiplexing. This is one of the switch modules. Think of these as like programmable relays. So there's inputs, and then there's outputs. And the output reacts however it's programmed to based on the various inputs. So you could have an input of more than one thing in order to make an output, or you can have an input of one thing to make the output flash, or one input does more than one outputs. And I don't know what the limit is, but there's a crap ton of outputs and inputs on these things. So this whole console piece here, I took the cover off, which is sitting back there, the two parts. And I've never really liked them. They take up kind of a lot of space on this left side, so much so that the original location of the driver's seat is not in the middle of the steering wheel. It's offset to the right some. So what I'm thinking is if I could take these things off of this like armrest kind of console thing and attach them to the flat wall back here and remove this whole shebang, I'll gain a lot of side space. And of these switches, I only need a few of them. Let's see, what do we have here? We've got geez, I can't see, man. You've got active noise. I probably don't need that. What that does is when you turn that on, it shuts off a lot of other things that make noise, like the radio, the AC fan, and some other stuff. I can't remember. I guess that was about it. Alright, so now this is the dimmer, increase or decrease. I think that's for the dash light dimmer. Alright, so I'm going to want to keep that one. This is the AC for off, vent, or AC with the compressor. What's weird is you can hear stuff clicking. So it means, the key's off. These computers are always on. And drain the battery. I know this thing's got a battery drain. And maybe there's something wrong with one of these things. I don't know. That it never shuts off for some reason. I don't know. But so here's fan, AC fan, low, medium, and high. Oopsie. We're going to want that. Strobe light on. We don't need that. These are indicator lights. This one and this one. This is a dummy and that's a dummy. So this is defroster fan. That doesn't work. I believe that fan is that guy. That doesn't work. It's powered with these wires. I can't get that to work, and it's not a fuse, so there might be a bad switch. There is an indicator on my dashboard when I press the code retrieval button over there. It tells me I got a bad switch, I think. So maybe that's a bad switch, and maybe that's why the fan doesn't work. So this is a driver dome light on and off. I want to keep that. There's another dome light in here for the back of the bus. I probably won't need that one. So I only need like 4 or 5 of these. This is for the door open and close. This is the master warning and the amber warning. I don't need anything here. Now these indicator lights could come in handy. I might be able to get this thing reprogrammed to do something for me, but really I only need a few of these. So anyway, what I'm doing now, I got a low battery, so I might cut out on you in a minute now. But I got my little label maker. Okay, a little P-Touch with some 6mm, I think it is, ribbon. And I just put a label right there for bank A. And that means this one's going to be bank B. I guess I'll go ahead and print a label for that too. And then I can unplug these two plugs. And then I can also unplug these two wires. These are the switches that control my electric mirrors. So if I unplug these and these, I can get that thing out of here so I don't have to worry about damaging the darn thing. And that'll make work here a little bit easier because I've got to get into this wiring harness back here. Does that help? I got to take the tape off of that like I did this so I can pull out these circuits. So what I'm going to do is I've already identified this one. This one was easy. This is the amber, it's got a little label on there, the right amber blinking light. So what I want to do is pull this wire all the way back to here someplace and cut it and label it in case I know I never will, but in case I ever might want to reactivate that circuit for something. That's a circuit that I already have. The fact that it blinks when you turn it on makes it pretty useless. But so you can see here, I've been doing the same already. Here is one wire that I cut, that this is the door open solenoid. And I'm not worried that I cut it. I'm going to terminate this so it won't short or anything in the future. But now this becomes a useful circuit if I want to use it for something, because all I got to do is flick the switch that I already have down here for door open, and this becomes hot. And it's already fused and everything. So I might decide to use that for fog lights or something. Who knows? And I got this one here. This is the door close solenoid. So this wire will come hot opposite this wire, right? Because it's either open or closed. So, I mean, that's very usable. That means I have a switch that's one way or the other, like house battery or chassis battery to a relay or something. Who knows? I mean, there's, you know, all kinds of possibilities. There's two. Oh, here's the other one. This one is the door switch. So this is an input. So when the door was open, this made a circuit to ground. All these are circuit to ground. So this would make a circuit to ground, and then it would tell the bus that the door is open. So I may want to use this as a warning for something, like I left the compartment bins open or who knows what, right? So yeah, we're gonna move on ahead and take the rest of that tape off and start to pull these wires out one at a time until I get back here or wherever they go. This is only one of the modules. And yeah, there's a lot of wires on there. You look back there, those big plugs. So here's our power supply. I just noticed we got that power supply and that power supply to feed all these circuits and to run this computer board. And somewhere in here too, there's a twisted pair of wires that will tie this in. I'm pretty sure there's a twisted pair of wires when I was reading the book that ties this computer in. There it is right there. I think that's it. There's a twisted pair of wires right there. See them? Right there. Let me give you some more light. It's green and orange. Twisted pair. That's the communication. Right? All these are on the same bus to communicate all these computers. Yeah. So technically, I could just unplug this whole computer. I might get some error messages because the computer won't be recognized in the main system's memory. And if I wanted any of these circuits, I could just reconnect them in the conventional way. Ideally, the thing to have is the regular diagnostic computer that you can connect to. There's a plug up underneath there somewhere, a round plug, and that way you can communicate to all the computers on board, and then you could program these switches any way you wish if you've got that. The downside is it's a few grand, at least $3,000 to $5,000 for one of those computers, which I'm not quite ready to pull out that many dead presidents. But anyway, so we're going to move forward. You know, I might do a test. I might just go ahead and unplug all these circuits from here and turn the key on and see if it throws up an error code or if these things just cease to function. That would be a nice test. Anyway, let me get back to work.